Okay, so today inshallah we are going to talk about sound, that how the sound is taken or recorded into the computer or into the uh, mobile phone, whatever it is. So sound is another feature which we rely on, and we want to record it. We want to record the sounds. So there is no voice for you. Hello. Hello. Yeah, can you hear me now? Hello. Yeah, I think you can hear me now. Yes. So, Sarah.
Too late.
Yeah.
Too late.
No. We just started. So I think the sound is okay. You can check, Mr. Sari Ibrahim. You can check your settings. Fine. So sound is another thing that we want to take. We want to take that into record it. We want to digitize it. Okay. Now, what is a sound first? The sound is vibration in the air. Vibration in the air. When we speak, there is some vibration in the air. Because if you hold a finger over here and you speak, you can feel the the vibration. Even if you hit a piano or a thread, you hit it, you'll when the thread vibrates, it creates a sound. So sound is nothing but vibration in the air. In the air, there is a vibration. When the vibration takes place, the sound comes. Okay. So now we can think of a sound in this diagram, or like this. We can think of a sound uh, in the in a graph of how far the air particle moves up and down. Okay, so which is shown in this graph. Okay, now here the distance it moves either way is called as an amplitude. That is the up and down, the maximum up and the down. Okay, the either way it goes, what is the height it will go and what is the bottom it will reach, that is called the amplitude. And one completeness of one backward and the forward movement is called the frequency. So if you start from here going back and coming to the forward till here, this is called the frequency of the sound. Okay, so two things here you have, what is amplitude and what is frequency. Amplitude is the distance it moves, the air moves either way, and the frequency is the rate at which the sound completes one backward and the forward movement. It's called the frequency. Now we can also take the sound, as we can take, we saw how we can take the image into the digital form, that is by sampling and quantization. Sampling is dividing into samples, dividing into pieces. Now here in the image we saw that we divide into rows and columns. We divide the picture in the image. How it was with the image?
Pixels.
Yeah, divide this like into pixels, right? Divide each into rows and columns, small boxes. In that boxes we assign the pixels. For the sound we cannot divide like this, right? Because sound is not a picture. So sound we cannot divide like this. So what we'll do for the sound is that we'll take the samples. For example, in 1 second of sound, in 1 second, let's say in 1 second it's say hello. This is in 1 second. In this 1 second we'll take samples of the sound. We'll take let's say 10 samples. 10 samples of the air movement, okay, is taken for 1 second. Okay, so as shown in this one, this is the time, okay, and this is the samples what is taken. So at the time t, the frequency was this one, and the amplitude with the frequency was this one, and at the time next t plus 1, t plus 2, t plus 3 and 5t, and t2, t3, t4 and t5. At the time 5, this is the sample. So you see for every 1, 2, 3, 4, this is 2. Sorry. So you can see that this is 1, this is 2, 3, 4, 5. For every second or a part of the second, we'll take the sample. That what is the frequency of the air? What is the frequency and the amplitude? Okay, we are going to take the samples, and for these samples we are going to store. We'll assign some binary numbers and store in the hard disk or store in the computer. Okay, so this is called sampling and quantization. So in order to digitize the sound waveforms, we take the samples of the sound at a small time of interval. Such process is called sampling. Okay, and an image is we take the samples of rows and columns, right? For the image, we divide into pixels of rows and columns, and a waveform is a series of discrete time interval, that is units of time, that is in time for every second or for every half second, for every microsecond, we are going to take the sample. So the number of times per second we take the sample is called sampling rate. So if it is 10 samples in 1 second, the sampling rate is 10, because 10 samples per second. In 1 second, if it's 10 samples, we say that the sampling rate is 10. If it is 20 samples in 1 second, sampling rate is 20. So this is called the sampling rate. The smaller the interval, better the sound. If you have many samples in 1 second, the sound will be more better, because you have the more data about the sound. For example, in 1 second, if you take 10 samples, and in 1 second if you take 50 samples, which will be the better? The good one will be 50 samples. More samples, you have more better sound. To save, to get it back for you. And for example, if I say hello, this sound hello, the sound of this word hello, okay, is stored as a sample. So let's say it is in 1 second. In 1 second, if I take only 10 samples out of this sound, okay, and in the other way I will take 50 samples, which is the better? 50 samples is the better, because in 50 samples you have more samples, more accurate sound you can get. When you take back the sound, you can get more accurate sound. So that's what it says, that a smaller interval is the better, and which is more samples will give you the smaller interval of time between the samples. So it brings the encoding closer to the original sound, that is giving you accurate sound. So we can never make a perfect digital representation of an analog quantity, because we always lose information between time we sample a waveform. We definitely will not get, because we are taking samples. We are recording samples, not the complete one. So definitely we will not get the exact one. But we can get a sound which is similar to what you are recording. You don't feel it, and we cannot feel that there is a difference. In such way it is recorded. Okay. So it is also impossible to make a perfect digital coding for an analog picture, because it loses some information between the pixels. We have seen this in the photo, that some pixels will lose some information. So for that we need to increase the resolution. If we increase the resolution, we will get. Now back to quantization is the second stage. After we take the samples, we have to quantize it. Quantization, it is a second stage in the process taking an image or a sound across the boundary. That is, it is a process of converting each sample into a suitable number for computer storage. Suitable number, it is suitable binary form in zeros and ones. Okay, so it is in general, if we say, if you want anything you want to digitize, it is two-step process: sampling and quantization. Sampling and quantization. What is sampling? Sampling is taking the samples of the analog quantity at a small interval of time, or making the analog quantity into samples and giving the numbers to the samples. This is first taking the samples, that is sampling, and assigning the numbers to it, zeros and ones, that is called quantization. Okay, so the smaller interval taking the samples, the more accurate our representation analog sound will be. You have the very small intervals of between the samples. So if it is 10 samples in 1 second, so there is an interval of, for every 10 microsecond you are going to take the sample. If you have 50, it is more accurate. Okay, so smaller intervals which means more samples you will take. Smaller interval, it means more sample. More sample, it means more storage. You need more storage. So several formats exist for this sound digitizing, which depends on the precision. Like example, MP3, WAV, or MIDI. These are different formats that you can save the sound. You can save in MP3 format, or WAV format, or MP4 format, whatever the formats. I think you know better than me these formats. Okay. So what is the input device for the sound? Is the microphone. Microphone, what you have in your mobile phones, and this microphone, all this the input device for the sound. Okay, so a final word for this crossing the boundary, that is, we are taking the analog quantity, photo, video, audio, diagrams, pictures, into the digital, making it digital into the computer. What is this? A final word to say that any feature of our world that interests us into the digital world can be taken by two steps. Number one, breaking the target into parts, that is called sampling. Number two, mapping each part onto a binary number called quantization. This can be a question for you in the midterm exam. What is the process of converting analog form into a digital form? Or what is a two-step process? Or what is sampling and quantization? Okay, this can be important, can be a question for you in your midterm exam. So once this information has been captured, programs are written that will change them in a way that suits it. Change, it means making editing. So you have a program to make editing in the photo, like Photoshop. You can edit in the sound. You can edit the video, right? So there are many programs, softwares available for you to make changes in this program. In this data. Going back, it means that after you save it, how to take it back. And we take a photo, it is saved in the memory. Now how to see it back, that photo? We record the sound, it is saved in the memory. How to listen to that sound? What we need to listen to that sound, right? So it is simple that if we cannot take it back, then there is no use of saving it, right? So for example, I am recording a sound. After recording, I cannot hear that sound. Then what is the use of recording that sound, right? If I take a photo, of you, and I cannot see that photo in the back, what is the use of taking that photo, right? So it is important that we need to take that data back to us, right? After converting into digital form, saving in the memory, we got to take it back into the digital form. So that is we need to check that how we can take that back into the digital form. So sending a digital representation back across the boundary is a 3-stage process. Number 1, identifying the output device to be used. In which output device you want to take it back. For example, you want to see the photo, you click a photo. You want to see that photo back in the mobile phone, or you want to see in a monitor, or you want to see in a tablet or in a laptop. What is the device? Or in a projector? Which device, what is the output device in which you want to see that? Or if you record a sound, what is the output device for the sound? Speaker, right? So this is identifying the output device, number 1. Number 2, arranging the numbers into form that can be handled by the output device. Arranging the numbers is, we store the numbers, we store zeros and ones. When we take that into digital form, when you take the photo into digital form, what you store? You store zeros and ones. So these zeros and ones, again we need to arrange in a format that give us like the original one. Okay. Number 2. Number 3, interpretation of the code by the output device. When we arrange it, the output device should interpret that this code is for this color, this code is for this line. Okay, this should be done by the output device to give you the exact image or exact sound or exact video. Okay, so it is 3-step process. Number 1, identifying the output device. Number 2, arranging the numbers in a form that can be handled by the output device or understood by the output device. Number 3, interpretation of the code by the output device. Okay, so in a computer we have different output devices. Those are monitors, printers, plotters, speakers, okay, and other output devices. Let us talk about monitors. There are 2 main types of monitors, CRT and LCD. Cathode ray tube CRT monitors, those which were you have seen, I think, these CRT monitors, the big one. Okay, at the back you have the big one, and there is a bulb, there is a light behind the scene. I mean, if you look from the back, you see a bulb over there. Okay, we used to saw that when we were kids. We had a TV at home with like a CRT, and we used to see the bulb from back. So it is a CRT monitor. This CRT monitor contains millions of tiny red, green and blue phosphorus dots. It's a chemical, phosphorus dot, that glow when struck by an electron beam that travels across the screen to create the visible image. That means there is a light comes and hit this phosphorus, this red, blue and green. There are 3 phosphorus. Okay, when the light comes and hit it, it will glow, it will light up. Okay, and it will show its color. So this light which is coming has a variation, and a very little light or very high light. It depends what type of color you want in that. Okay, so when it hits, the electron beam travels across the screen to create the visible image. The electron beam sweep across the screen. It means it goes across the screen in the same scanning pattern, the raster scanning pattern. Pixels on CRT are formed by 3 colored phosphorus, that is red, green and blue phosphorus with the 3 color. Okay. Professional graphics still favor the CRT monitors for their color accuracy. The next we have the LCD, liquid crystal display. I think this one also you have seen. It has the 2 sheets, the flat one, the flat monitors. So LCD monitor uses crystal liquid matrix between 2 opposite polarizing filter sheets, and the front they have the 2 sheets over there. Okay, like a paper like sheets or a plastic sheets. Okay, so a backlight creates a light that passes through the first sheet. At the same time, the electrical current causes the liquid crystal molecule to align to allow varying levels of light to pass through the second sheet and create the color and the images that you see. and pixels LCD are made of crystal molecules. LCD monitors are preferred over the CRT because they take less power, they don't have that bulb and all, so and take little space and free from flickers, and hence less tiring to work on. It will not show any flickering, any flicker effect is not there. So monitor of this LCD and CRT, they both display the digital format. It's called digital display monitors. Okay. This about the monitors. Coming to the printers, there are two main again in printers: inkjet printer and the laser printer. You know about the inkjet printer. These printers has the ink tank. Okay, when you open that cartridge, you will find the ink tanks. You can take out the ink tank, fill the ink, again put the ink. It has three colors, that is yellow, cyan, magenta and yellow, three colors. Okay, you go to any this ink shop, yeah, you can see that still it is there in the market. You can find that these inkjet printers, and it is cheap. You can get in 100 real, 150 real, you will find the printer. But it will not print much papers. It can print maximum of 100 pages or 150 pages only. Sorry?
Does the job.
Yeah, it does the job. Fine. So inkjet printers work by firing the tiny droplet of the ink at the paper from a moving print head to create the image. And it will throw the ink on the paper, which will make the image. Okay. Such printers can print both color and the black and white. Its cartridge comes in three parts: cyan, magenta and yellow, indicating the color model CMYK that printer uses. Number two, the laser printers. These laser printers are very high quality print by firing a laser beam at a rotating light sensitive drum. There is inside a drum type and a roll type you have inside. Okay, that is light sensitive. So it will put the light on it to create an image on it, and that image in this way the laser draws a negative image on the surface of the drum. On the drum it will create the image. The drum is something like this, in this format, a drum which comes like this. On this it will throw the light to create an image. Okay, it is light sensitive. When you throw the light, it will create an image on it. It is something like drawing on it. Okay, so the charged drum is then rolled in positively charged toner, a dry powder type of ink, which sticks to the charged image on the drum. Then the toner is transferred on a paper using the heat and the pressure. The drum and the toner, that will get the ink on that drum, and that is again pasted on the paper. Okay. So laser printers generally print only in black and white color, and we have this color also. Okay, but it is a bit expensive. So if you see, I think laser color printer you will get around 500, 600 real. Okay, starting price might be 400, something like that. If you compare to the inkjet, you will get 150, 100 real, 120 real. You can get from HP. Okay. So both they produce the digital output as they make the graphic and the text firing on the laser or ink through a square matrix of tiny holes. They produce the digital. We also have plotters. Plotters, they are like drawing machines. How you will draw the photo or the diagram on a paper, plotters will also draw like that. Plotters will have you draw using pencil or pen, right?
Yes.
Plotter will also have that pen or pencil that will draw on the paper. So a plotter is a special printing device mostly used by architects or the engineers and the map makers. The printed output is produced by moving pen across the paper. So it will move the pen. So there will be a pen which will move like this, like you are drawing, like a human beings are drawing. The printed output produces moving pen across the paper. Plotters are more suitable for line drawings, which is architects, for instance, use them for drawing the building, drawing the maps, drawing the road map. They use only lines and all, right? So there they use the plotters, and this produce the analog output, which is similar like the human drawing, how you will draw the same fashion. Then loudspeakers, they also produce the analog output, and they are for the sound. Loudspeakers, I think, do you have seen what is there inside the loudspeaker? There is a magnet and there is a paper drum. Okay, so when this electric pulse comes to this one, this generates a pressure, and that drum will vibrate. The paper on the drum, it starts vibrating. The vibration of that will create the sound. Okay, and that comes as a sound. Fine. This is all about converting from analog to digital, and from again digital to taking back into the analog world. The next is more on number system. This is conversion from decimal to octal, octal to decimal, binary to octal, binary to decimal, and decimal to binary. We have seen this in the last class, right? So just give me a brief idea that how we want to convert a decimal into octal. How to convert decimal to octal? Forgot. See, this is important. You will get in the question in the exam. Problem solving. How to convert a digital into, the decimal to octal. So this. We have, let's say we have a number called 235. Let's say this is a decimal number. Okay. We want to convert this into octal, which is octal means base 8. Okay. Tell me if you know. Divide by 8. Divide by 8. And a 235 divide by, you are going to divide it by 8. So how many times it will go? 2, 3, 5, 8. You don't know? So if you can use the calculator, I'll show you the simple method that how you can make it by using the calculator. 235 divide by 8, you will get 29.7375. So it means that it will go 29 times. The remaining is 0.375. You take that 0.375 into 8, that is 3. 0.375 into 8 is 3. So this is remaining. Remaining is 3. Again 29 is again divided by 8. It is divisible by 8. So how many times it will go? 4 or 3? 3 times it is 24. Remaining 5. Okay. 3 times 24. So if you take 24 out of 29, remaining 5. So now it is 3. 3 cannot be divided by 8. So we stop here. We will take from the bottom to up. 3, 5, 3 is the octal number. So you got how to convert from decimal to octal, base 10 to base 8. Clear? If you 8 power 2 from the right. Okay. So it's a 3 into 8 power 0 is 3. This is 40 and this is 64 into 3. So what is 64 into 3? 64 into 3, 192. So 192 plus 40 plus 3, 235. This is 1922. So it add this one, it is how much? 235. Okay, that's what it is, 235. What? So if you want to convert decimal to octal, divide by 8. octal to decimal multiply by powers of 8. 8 power 0, 8 power 1, 8 power 2. Clear? So in the same fashion for binary number, if you want to convert any decimal to binary, divide by 2. Binary to decimal, multiply by 2. Power of 2. Powers of 2. So for example, let's say this is 1101 is the binary number you want to convert into decimal number. So you will take it 1011 and multiply with powers of 2, that is 2 power 0, 2 power 1, 2 power 2 and 2 power 3. So here it is 2 power 0 into 1 is 1 plus 0 plus 4 into 1 4 plus 8 into 1 8. It is 13. Okay, so it is 13 to the base. And we want to convert that 13 into binary, divide by 2. So it goes 6 times, remaining 1. It is 3 times, remaining 0. 1 time remaining 1. Right? And you take from the down to up, from bottom to up, it is 1 1 0 1. The same procedure, but there we use 8, here we use 2. Okay. So this is the conversion, more on numbers. This is what it is. It is showing another method converting binary to decimal is that you take all binary numbers and assign the numbers over here, like you can see here. If you get binary to octal or octal to binary, what you will do? First convert to decimal, then from decimal to the other format. In the midterm as well as in the final exam also. But midterm is sure. Final exam also you may get this. But for the coming midterm exam, it is sure that you will get this. For the coming midterm exam. Fine. So this is about the conversions. This is by dividing the number. You take these numbers in a binary. Divide by 2. Decimal to binary, divide by 2. Binary to decimal, multiply by the powers of 2. This is octal. Octal to decimal, multiply by powers of 8. Decimal to octal, divide by 8. Okay. So if it is octal to binary, convert first octal to decimal, then decimal to binary. Okay. So this is all what we have in this meeting, that is meeting number 3. For the next is meeting number 4, which is also there for us for the midterm exam. So we'll continue.